Applications of linear functions, College Algebra, Chapter 1, Section 6. Okay, applications of linear functions. Applications is a fancy word that we like to use in math when we really mean word problems. We're going to take what we've learned and we're going to apply it to real-life situations. Now we have a few tips here when you're solving application problems. First, you should read the problem. Make sure you understand it. Assign a variable to what you're being asked to find. If necessary, write other quantities in terms of this variable. The second thing you want to do is write your equation. You need an equation that's going to relate the different quantities given in the problem. You might want to sketch a diagram and look at formulas. Then you're going to solve the equation, determine the solution, and then you're going to check your solution and ask yourself if it seems reasonable. You may want to round it, or if you have multiple solutions, some of them may need to be thrown out. First word problem. Televisions often have a 16:9 aspect ratio. This means that the length of the rectangular screen is 16/9 times the width. If the perimeter is 136 inches, find the length and the width of the screen. I suggest you make yourself a sketch, write down what you know, write down the formulas that are involved. Pause the recording, give it a try, resume the recording to check your answers. Here's our solution. Notice we have a sketch, we have a rectangle. The length is 16/9 times x, while the width is x. We also have a formula to use, and that's our perimeter formula. Perimeter is twice the length plus twice the height. Now we know from the problem that the perimeter is 136 inches, so we put that in place of p. We know from our diagram and the information given that the length is 16/9 times x, and the width is x. So we put those quantities into our equation, and then we solve it. Multiplying the 2 times 16/9 gives us 32/9 x. And then the next thing they did was combine like terms. Now, if you want to, you can pull a trick we've used before, multiply everything by 9 to eliminate the denominator. Or you can do what they did. They changed 2x into 18/9 because 18/9 reduces to 2 and has the same denominator. When you combine those, you get 50/9 times x, and then they divided both sides by 50/9. The width is 24.48 inches, and then we take that x and multiply it by 16/9 to get the length, and that is 43.52 inches. We can also confirm this graphically. We can set the left-hand side of the equation equal to y1 on our calculators, and the right-hand side equal to y2, or vice versa. That gives us two lines. 136 will be a horizontal line with the other line intersecting it. Use the intersect function in the calc menu to determine the answer. We notice that x crosses this line at 24.48. Then you'll need to multiply that by 16/9 to get the length. Okay, mixture of concentrations problem. How much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50% alcohol? Let X represent the number of liters of pure alcohol to be added. I really like the way they diagram this out. It helps me think it through, and I think it'll be a benefit to you to do this. You've got 3 rectangles. Across the top of the rectangles, we're going to put the liters of liquid. Across the bottom, we're going to put the alcohol concentration. So for the liters, we have 20 liters. We have an unknown amount. We don't know how many liters we're going to add. But together, at the end of this, we're going to have 20 plus X liters. Now at the bottom, we're going to put the concentration of alcohol. In the 20 liters, we have 40%, so that's 0.4. In the next rectangle, where we don't know how many liters we're going to add, we have pure alcohol, which is 100% or 1.0. In the final rectangle, our final product, our final liquid, has to have 50% alcohol, so put a 0.5 there. And then what you're going to do is the two numbers that are in the rectangle are going to get multiplied together. So we're going to multiply 20 times 0.4, 1 times x, and 20 plus x times 0.5, and that gives us our equation. So we've done the hard part. Now we just need to finish the equation. Now you may be wondering, well, how come these decimals all of a sudden became integers? Well, what they did was they multiplied everything by 100 to remove the decimal. You can do it that way, or you can leave it as a decimal. It doesn't matter, whichever way is more comfortable for you. In the end, when you solve for x, you should get 4. So 4 liters of pure alcohol need to be added to the mixture to get the amount of alcohol required. Now let's look at a break-even analysis. This is an economics kind of problem. You have a company that produces high-definition DVDs of live concerts. They're going to put an ad in a trade newsletter. The cost of the ad is $100. Every DVD costs $20 to produce, and they sell them for $24. So we're going to write the cost as a function of x, and x will be the number of DVDs produced because we don't know how many that will be. And then we're going to write the revenue as a function of x, which will be the number of DVDs sold. Pause the recording, see if you can give this a try, and then resume the recording to check your answer. Okay, our cost is going to be the variable cost times the number produced plus the fixed cost. The variable cost, it's variable because we don't know how many we're going to produce. So it's going to be $20 per DVD, 20x. The fixed cost is the charge for the ad, which is $100, and that won't change no matter how many DVDs are produced. So our cost formula is 20x plus 100. Revenue is the amount of money you're bringing in, and it's based on the number you sell. We're charging $24 per DVD. We don't know how many we're going to sell, so that will be x. So our revenue will be 24x. Now part C says, for what value of x does revenue equal cost? So we're going to take the two equations we found in A and B and set them equal to each other and solve for x. Pause the recording and try this, then resume the recording to check your answer. Okay, so when does revenue and cost come out the same? Set the two equations equal to each other and solve for x. And we find that when we have produced and sold 25 DVDs, our revenue and our cost are the same. In other words, we are breaking even. At 25, you're not making any money, but on the other hand, you're not losing any money. Okay, we're going to do two more things with this problem. We're going to look at it graphically and solve it that way to support the answer we got, and then we're going to use a table. So go ahead and pause this recording, put the information in your calculator, and see what you come up with. Here's what you should have. We have the two equations graphed in the same window. Our intersection is x equals 25, so when we've produced 25, we have it. In the table, again, notice that at 25, the cost is 600 and the revenue is 600. They're equal. By the way, if you notice that for numbers less than 25, the cost is higher than the revenue, which means you're losing money if you can't sell 25 at least. And notice that when the numbers go over 25, then you're starting to bring in more than you're spending, and you're actually making money. And number y varies directly with x if there's a non-zero number k such that y equals kx. And k is called the constant of variation. We've done direct variation before, both in Algebra 2 and 3, so this should be somewhat familiar. Let's try a direct variation problem from physics. Hooke's law states that the distance a spring stretches varies directly with the force applied. If a force of 15 pounds stretches a spring 8 inches, how much will a force of 35 pounds stretch the spring? You need to set up a direct variation equation using the fact that a force of 15 pounds stretches a spring 8 inches, determine the constant of variation, the k, from that, and then use that to determine how much a force of 35 pounds will stretch the spring. Pause the recording to give it a try and resume the recording to check your answer. Okay, here we have our direct variation. 8 inches of stretch equals k times 15 pounds of force, so k is 8 over 15. That means that our equation is y equals 8 over 15 times x. Now we're going to put in 35 for the amount of force, and we're going to simplify. You can actually cancel 5 on both sides there from the 15 and the 35. That leaves us with 8 over 3 times 7, which is 56 over 3. Changing that to a decimal, we get 18.6 repeating, or close to 19 inches. Now we're going to solve a formula for a specified variable. It says a trapezoid has area 169 square inches, height 13 inches, and base 19 inches. Find the length of the base by solving the formula A equals 1/2 h times b1 plus b2 for b1. What you're going to do first is you're going to isolate the variable b1 and then put the information in. Be sure you show your work, pause the recording, try it out, resume the recording to check your answer. So here we have the process of solving for b1. We multiply both sides by 2 to get rid of the 1/2. Then we divide by the h to get b1 and b2 plus b2 alone, and then subtract b2, and we have a new equation. 2a over h minus b2 equals b1. Now we can put in the information. We put in 2 times 169 for the area, 13 for the height, and 19 for b2, and that gives us 7 inches. Okay, we're going to do the same thing with this equation. We have perimeter formula, 2 times width plus 2 times length. Solve for L. Pause the recording, try it, resume the recording to check your answer. Okay, the first thing we're going to do is subtract 2w. So we have p minus 2w equals 2l. Then divide by 2. Notice they simplified a little bit here. L equals p over 2 minus w. The 2w and the 2 were able to cancel. Remember, if you're going to do that, you must give the 2 to both parts of that. You can't just cancel the 2w and leave it that way. So this should be your final answer. Now try solving this equation. This is the equation that helps you convert Fahrenheit temperature to Celsius. What you're going to do is you're going to solve for Fahrenheit for F, which will give you a formula to convert Celsius temperature to Fahrenheit. Pause the recording, give it a try, resume the recording to check your answer. Okay, the first thing we did was multiply by 9/5, and then we add 32. Now we're going to try a problem using similar triangles. It says a grain bin in the shape of an inverted cone has a height of 11 feet and a radius of 3.5 feet. If the grain is 7 feet high in the bin, calculate the volume of the grain. Okay, for this problem, we can figure out the volume of the entire cone very easily. We have all those dimensions. What we don't have that we need to figure out the volume of the grain is the radius where the grain is, because with a cone, the radius of the circle depends on where in the height of the cone you are. We're going to use the fact, if you look at the picture on the right, that we have two similar triangles here. We know that the overall height, the big triangle, is 11 feet. We know the height of the smaller triangle is 7. We know that the radius, or that other leg of the bigger triangle is 3.5 feet. We need the leg of the smaller triangle. You can use the fact that the large triangle and the small triangle are similar and set up a ratio to find the radius. Once you know the radius, you can find the volume of a cone. In case you've forgotten, the formula for the volume of a cone is 1/3 pi r squared h. Pause the recording, see if you can do this. Resume the recording to check your answer. Okay, so we've set up a ratio here. The ratio of the radius of the large cone to the height or triangle to the height of the large cone or triangle is 3.5 over 11. Now what we're going to do is we want to compare that to the radius for the small cone or triangle to the height of the small cone, which is 7. They don't have it all spelled out here, but if you have 3.5 over 11 equals r over 7 and you cross multiply, you end up with r equals 3.5 over 11 times 7. When you multiply that out, you get 2.227. Now you can use the volume formula, 1/3 pi r squared h. It's 1/3 pi times 2.227 squared times 7, and it gives us about 36.4 cubic feet. Here's some classwork problems to try. Pause the recording to try them, resume the recording to check your answers, and do this until the end of the slides.